A type of question that I would break down into, A, B, C, just like this. These are all the steps that you have to have when you draw a graph. So step A is just factoring anything that we can. The top is just x squared, so that doesn't break down. The bottom, what multiplies to -6 and adds to +1?
-2 and positive 3.
Okay. So then B, an X-intercept. So for intercepts, you're plugging in a 0 for the opposite variable. So an X-intercept is like when your y equals 0. So the first thing you probably do is multiply by that denominator. And 0 times anything is still 0. And you square root and you get x equals 0. So on my graph, we hit the x-axis at 0. Y-intercept, so for intercepts you make the opposite variable 0, so we plug in a 0 for all the x's, and we get 0 over -6, which is 0. So we plot our x and y intercepts. Those are just points on our graph. The asymptotes, we had rules for these. Vertical asymptote is x equals whatever makes the bottom 0. That's why we factored it, so we can quickly tell. What makes x minus 2 equal 0? So please write those as equations. On your graph, we draw those as dashed lines. So we have a dashed line at 2 and -3. I didn't leave myself enough space, did I? Okay, then we have to decide if it's horizontal or oblique. You won't have both, it's one or the other. And that's based off the degree. What's the degree of the top? 2. The bottom? 2. Remember, if the top degree is smaller, our horizontal asymptote is just 0. If it's the same degree, you divide your leading coefficient. So if you look at the original, it was 1x squared over 1x squared. So 1 divided by 1 is 1. If the top is 1 bigger, that's when we get an oblique asymptote, and we have to do long division. And I think there's an example involving that later on. If not, I will do one on tomorrow when we're reviewing. So if we have a horizontal, we don't get an oblique. So we have a horizontal asymptote. Then we just use our graphing calculator to get this graph. When you put it in, I usually just go with the original, put parentheses around the top. I know, he's been there for a while. They like the lights, he's not going to bother you. So do the top in parentheses and the bottom in parentheses. And plug that in. When you draw this graph, if you draw this, I am going to count off. Okay, this is a function. It has passed the vertical line test. It should be getting closer to your asymptote. So make sure you have a curve that is clearly getting closer to your asymptotes. The middle part, the only place it can touch the axis is where you have a dot. So it looks like this. Right, so those are high point value questions. I will definitely, I have some additional review that I want to work before we take our finals, so either tomorrow or on Thursday, I will definitely do another one of these with you guys. Number 4, question D. So x to the -2. That just means the negative exponent moves it down to the bottom. When we had these, most of you tried to get rid of the fraction. So you just multiply by what's on the bottom. So if you take everything times x squared. 15 divided by x squared times x squared is 15. 19 divided by x times x squared, so 1x cancels and you get 19x. 6 times x squared is 6x squared equals 0. So we could do box simple here. If you also did quadratic formulas, it'll work out as well. So we need two things. So it's multiply the 90 and add to negative 19. So you could do a negative 9 and a negative 10. So if we set each of those equal to 0, we get 5/3 and 3/2. You have to make sure on question 4 that you are checking all of these. Like on A and C, both of those you get answers that don't work. Like on 4A, you get -5 and 2, but when you plug -5 back into the equation, it doesn't work. On C, you get 3/4 and 4, but the 3/4 doesn't work. So you have to make sure on those radical problems that you're checking your answers. Plug them back in. If you plug both of these in, they do work, so we're good.
I got 1/2 and 5/3.
Chunk. So you have to be able to go back and forth between a log and an exponential. So remember the definition, you always start at the base. So this is 4 to the y power equals 1/16. We tried to get a common base. 16 is 4 squared. What would put it on the bottom? So y equals -2. I had at least one person that didn't really work it out. They just knew that from the beginning, because this is like saying 4 to what power equals 1/16. So if you recognize that, that's also okay. Number 7. If you have two logs being subtracted, what do you have to do to combine them? Divide. So this is log base 7 of 3x plus 2 over x minus 2. So then we can change that to an exponential. So 7 to the first equals 3x plus 2 over x minus 2. What is 7 to the first? 7. So if we want to get rid of the fraction, we can multiply over the x minus 2. So we get 7x minus 14 equals 3x plus 2. If I subtract over my 3x, add over my 14, and x equals 4. Again, on these logs, you should always be checking that when you plug this in, the argument is positive. 3 times 4 plus 2 is positive. 4 minus 2 is positive. If either of those was a negative, what would we have to say? No solution.
If what was the negative?
If the argument, whatever you're doing the log of, has to be a positive number. And question number 8. Okay, so I have somebody I know that was able to just simplify this. What is log base 6 of 36? 2. It's saying 6 to what power equals 36? It's 2. But if you didn't catch that, you just do the definition, change it to exponential. So 6 to the 5x plus 3 equals 36. We want a common base. 36 is 6 squared. So 5x plus 3 equals 2. Subtract your 3. We get -1/5. Is that okay with you? So for tomorrow, I'd like you to do the next page front and back. So that's 10 through 21. Now some of those are going to be pretty easy, or should seem easier because it's getting into like systems of equations, some matrices, some of the stuff that we just did recently. So hopefully those will go a little faster for you. So you have the rest of the hour to work on that part. Ask questions if you need to. Check it, either the one that's typed up